Hi folks, welcome back. This is Tom Affolter, and today we're going to talk about C# variables. We'll look at arrays, and we're going to try to understand lists as well. So basically, elements of storage. How do we store information? So the heart of programming is the ability to store information either temporarily or permanently. We might store information temporarily in computer memory, or we might store it permanently by writing it to a hard drive. So far we can store data in properties of objects. So we could go back in and, for example, create a text box in a Windows form, and in that text box I can write a name in that text box and get to that information in that text box through the text property. But sometimes objects like that are way too sophisticated and way too large to store simple values. We don't need an interface. And let me give you an example of that. If you need to store groceries that you just purchased, you really only need to store them in a cupboard. You wouldn't go out and buy a brand new home just to store your new groceries, because obviously that's overkill. The fact of the matter is if I need to store a name, and that's all I want to do is store a name or store a number, I don't want to go out and use an object that already exists like a text box or a label to do that, because believe it or not, those text boxes and those labels are enormous objects that take up a lot of user memory. And the user memory that it takes up are based upon the properties and the methods that are made up of that object. We don't need any of those. I don't care whether I can backspace in a text box when I need to store something. I just need to have access to my storage. So another example I might say is, if you need to store a number, okay, it's akin, I guess, to storing water. If you need to store a thimble full of water, you can use a thimble. You're not going to use a swimming pool. And that's basically what we're going to talk about now, is how can we effectively and efficiently store information? And the heart of that is variables. Many of you have already taken a math class in which in the math class you use variables. You go back in and you say x is equal to 5 within a formula. And basically anywhere you see x, the number 5 can be replaced. And we're going to talk about that. So let's talk a little bit about early storage so we understand how storage takes place today. In the early days of programming, programmers would pick out binary memory location and store a value. So imagine we've got this mainframe computer, we're back programming in the 1970s, maybe the 1960s, and we need to store information. What we would do as a programmer, because we had access to this vast amount of memory, generally about 1K, so it wasn't a lot, but we would go out into that 1K of memory and we'd find a memory location. We'd write down the memory location that is in binary. We might convert it into hexadecimal, but nonetheless, we'd write down that storage location. Then we would decide what we want to store in that location, and then we'd write how many bytes it took to store it. So I could pick a location in memory to store the number 55. I would have to tell it, okay, I'm going to store at this location 55, which means it's going to take up, let's say, 10 bytes of information. And later then, I would know that if I go to that location, that numeric location, and grab what's there, I'd be pulling out the number 55. And that was uber complicated in those days because I had to actually manage the memory. Programming has made that dramatically different. And in fact, during the second generation of programming languages, what they decided to do is they said, let's let the computer do the work for us. I mean, obviously, I can go up and look and say, where's memory not being used? But I could also have the computer do that for me. So during the second generation of programming, language developed a way to have the operating system do the work for them. The operating system would automatically locate a spot in memory to store a value. Rather than you remembering where in memory your value is stored, you just provide a descriptive name to that value. Say, this is my total value. Just as the internet is maintained by IP addresses related to an easy to remember domain name like Microsoft.com isn't really a location on the internet, Microsoft.com points to an IP address. The same thing holds true with variables. And the beauty behind this is it's done behind the scenes for us now. We don't have to worry about any of the complicated aspects. All I have to do now is say, I want to create a variable by this name. Okay, and the moment I do that, it goes out and looks for a variable location, and then I tell it this is the type of data I'm going to hold. And by telling it what the type of data is, it knows how many bytes of information it needs to store automatically. I don't need that. In fact, that's maintained within the variable name itself. So if I say store 55 to total, I don't have to do anything other than that. Probably have to go back and tell it to create a variable and call it total, but then I can put 55 in that, and anytime I refer to total, I'm going to be referring to 55. So let's talk a little bit about how we declare a variable. Before, in most languages, not all languages, but most of the sophisticated languages require you to declare a variable. That means you tell it, this is the variable that I want to use, and this is the kind of value that it's going to hold. So I might go back in and say, this is my total variable, and my total variable is going to hold a double precision number, which means it's going to have an integer or something inside of it. It's all I've got to do nowadays to make that work. So just as in a map, a location, maybe you might have a city called Richmond. The city of Richmond on a map is a specific location. So I can refer to Richmond, but in actuality, I'm talking about the entire city of Richmond. That would be an example perhaps of a variable. The name Richmond represents that entire city. Whereas a memory location like price of shoes might point to a specific price, like in this case, 1995. So let's talk about declaring variables in the C family of programs. So it's going to be the same, basically the same in C++, certainly C# and Java. And what we do is we start off with a data type. I'm going to tell it, I'm going to create an integer data type here, and that integer data type tells the computer automatically to store 4 bytes of information. Then I give it a name. In this case, I'm going to call it my age. So anytime I refer to my age, it's going to go to that memory location that it created for me and grab that integer out and bring it back to me. If I try to put something in my age that's not an integer, think of this as a giant container like a cup. And I need to make sure that whatever I put in that cup can hold. I might have a cup for hot, maybe a cup for cold. I might have a big giant cup for large drinks, or a tiny shot glass type that holds just a small amount of liquor or liquid. In this particular case, that would be the equivalent of going back in and putting the data type. What size, how much information do I need to set aside for it? Because I certainly don't want to set aside too much. That's wasting memory. But if I set aside too little, that's going to cause an error. So what you see on the screen right here, int my age, is how I declare a variable. So a variable is used to temporarily store a string, a number, a date, maybe a Boolean setting. And a Boolean setting is simply true or false. I might, when you log in, go out and look at your membership and say, is this a lifetime member? And I could set a Boolean to store either yes or no. And later, as you do things in the program, I can look at that variable and say, if it's set to yes, allow them to do this. But if it's not set to yes, then they're not a lifetime member. So numeric variables can be assigned a level of accuracy. That's the important part. How big is that cup? So it can be from a simple integer that's just going to hold a very tiny number, maybe a number less than 256, all the way up to 300 digits of accuracy to the right and the left of a decimal point. I don't know what you would name a number that has 300 digits. I don't even know if technically it has a name. I'm sure some geek somewhere sat down and given that a name. Once you get past a gazillion, I don't even know what that number is. And in actuality, gazillion's not a number either. So let's talk about data types. If I've got this cup and I'm going to store information in it and I want to pick the right container to store my values, what kind of cups can I pick? Or what kind of data types can I pick? And if you look at the left column on the screen here, it's going to show you the most common data types that we have out here. So you're going to see the very first one says Boolean, and it's logical. That means it holds a yes or a no or a true or false. It tells you how many bytes that it holds, in this case 2 bytes to hold a Boolean value, and what can I put into it? I can put in a true or a false in it. Going to the next one down, I have byte here. And byte holds a binary number. Notice it only takes up 1 byte of information, but it can only hold a positive number between 0 and 255. Then I've got this data type called char. Char holds a single character. It takes 2 bytes of information. And by the way, 2 bytes of information would be the equivalent of 2 characters. 2 characters. Now, why does it take 2 characters to store 1? Well, because the first character is the value, and the other byte is going to hold all that other information, like the memory location, everything it needs to know about it. So it's going to take a little bit more data than a simple char. You look down the list here and you've got a date time data type. And that date time data type will hold a date all the way from the year 1 all the way up to the year 9999. Now, why do I want to have a date time? Because by having a date time data type, I can now do math on date times. I can have a variable that holds one date and another variable that holds another, and compare the two and tell how many days or hours or minutes are between it, or I can add numbers onto it and it's going to give me back a specific date. You'll notice there's a couple of data types in here, like the decimal and the double in here. And there's also another one I'm not showing here called money. And they're all of the same basic concept. They allow us to store numbers that have decimal places on it. So for years and years, we used to use decimal. Decimal was the common one, and decimal would allow, it takes a lot of information to hold this data, but it took 16 bytes of information in order to hold 29 digits of accuracy. That's a pretty accurate number. Again, there's not too many numbers that we can't deal with when we're dealing with a decimal. But as time goes on, Microsoft added some new data types out there. And again, part of that was to try to be very similar to Java. They're trying to make C++, or excuse me, C# similar to Java. They added this data type called double. Now, double is going to be of the decimal types, most likely the one you're going to want to use, because it's much better than decimal. If you take a look at it, first of all, it takes half the memory location, but look at this. Whereas decimal holds 29 digits of accuracy, that double is going to hold 300 digits of accuracy to the right or the left of that decimal point. And it's going to do it at half the memory that we did with decimal. So does that mean decimal shouldn't be used or it's wrong? Absolutely not. If you use decimal correctly, there's still a lot of developers that will use decimal. There's still a lot of textbooks that will use decimal, but double tends to be the better way to do it today, and we're going to see some examples of that as well. Then you'll notice that we have a data type called int, which is an integer. That's a whole number, no decimal places at all in it. And it will allow me to hold a number from what, minus 2 billion blah 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 to a positive 2 billion blah blah blah. And then down below I have a long. Now these are very closely related. The difference is that a long is a really big integer. It takes twice as much space, but whereas this one has an accuracy of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the long integer gives me an accuracy of 19 digits. In my career, there's very few times I've ever had to use a long integer. Most all data types I ever deal with will work within this number scheme here. Then we also have what's called an object. We're going to talk about this later, but I can store, in fact, every object that we're going to deal with will be stored somewhat to a variable. It's outside the scope of what we're talking about right now. We'll come back to this one a little bit later. Let's jump down to short here. Short is also an integer, but notice that it's a smaller integer. It only holds as high as about negative 32,000 to a positive 32,000 in here. Again, you can use this, but the moment you put in 32,768, this guy is going to fail because that number would be too large for this container. You're going to get an error back. And then we have another one called a single float number. And a single float number is a smaller version of double. You'll see that it takes half as many bytes, and its accuracy is not quite 300. I guess if you do the math, it's about 45 approximately. So it's a smaller decimal type number. This probably would work for most of what you're doing here. We'll talk about that in just a second, my suggestions. And then the last one we have down here is a string. And a string holds anything that's not going to be numeric or not logical. For example, any name I want to put in here, or any non-numeric number I would put in a string. For example, a social security number. You don't want to put a social security number in as an integer, because if you did that, it would take the first 3 numbers, subtract the second 2 numbers, and then subtract the last 4 numbers. So the litmus test, you generally give a number to determine, is it numeric or is it just numeric characters, is, do I ever have to perform math on it? You don't average social security numbers. You don't average your student ID numbers. You don't average phone numbers or add phone numbers together, and those would be ideal strings. So not just the things you think of in terms of words like names, would you put into that? You can put pretty much anything into it. Now when it comes down to it though, let me correct this. When it comes down to it though, there's only a certain number of data types that I would recommend you really focus on. You don't need all those data types out there. Now had we been taking this class 20 years ago from me, I'd have drilled you on the precise data type because memory was a commodity back in those days. Those are the days when computers had 256 megabytes of memory, if you will, and there wasn't a lot of memory to go around. By the time you loaded the operating system and your program and your data, you didn't have a lot. So programs were written far more efficiently in those days. Nowadays, we tend to be a little bit sloppier, but the sloppiness, I don't want to use the word sloppy, is not the right word. We're not as careful as we used to be because now we're dealing with computers that have upwards of 32 gigabytes of memory in it. So memory, where it used to be the most expensive aspect of the computer, now has turned out to be one of the lesser expensive aspects. So what I've got here in the gray on this slide are those data types that I don't require, but I recommend that you focus on. So you want to focus on Boolean. You're going to use Boolean a lot. You're going to use date time a lot. But notice I've got double selected here, and I don't have single. Why is that? Well, because I'm going to waste 4 bytes of information, perhaps storing a smaller number that would maybe fit in single, storing into a double. 4 bytes of information when I'm dealing with maybe a computer that has, 8 gigabytes is insignificant. It's insignificant. It's not that big of a deal. These gray data types here are going to work for the vast majority of what you want to do. And of course, at the very bottom, we have to use string. Now, I'm not going to tell you that you don't need to go back at some point in time and maybe use a different data type, especially if you put a number in that is too large. If you exceed this number here, an integer on the right-hand side, this 2,147,483,647, if you exceed that, then you're going to want to go to a long integer so you can put that in. What will happen though is you're going to find that out during testing. You're going to test the extremes of your data. If you're putting, for example, if you're storing an age of a person, you're going to test out the age whether they're 0 or whether they're 105, just to make sure everything works. So you want to test the extremes out of what you expect your data to be, and if your extremes show that you need to use a long, then you'll use a long. But in my entire programming career, I don't believe I've ever had to use a long. And of course, I don't use short because I'm going to pick double. It's just a suggestion. You don't have to follow it. You could choose a decimal if you want. Unless I tell you specifically a data type to use, as long as it works, it's going to be your choice. As time goes on, you're going to perfect how you deal with data types. So, what are the variable naming rules that we have to cover? We're going to go back and take a look at some example of this. First of all, your variable name can be between 1 and 255 characters in length. So you can write an entire, 255 characters is a long variable name, and I would totally discourage that. You want to keep your variables very short and succinct. You want to probably not go more than 15 characters because you want to be able to look at your code and make it very readable. I can't imagine trying to read a variable that had 255 characters in the variable name. So if you're dealing with somebody's total income, call a variable total income. Okay? But it must start with a letter. You can never start a variable with a number or a punctuation mark. It's got to start with a letter. And you can't use spaces or any other kind of punctuation in the name. You can use underscores if you want. Some languages will actually let you use a hyphen. How do you know it? Well, you type it in, and it will tell you right away when you type it in whether it's a valid variable name. At least the editor should do that. I know Visual Studio does that. You cannot use a reserved word for a variable name. So far the reserved words that we've talked about are data types. So I can't declare an integer and call it double. It's going to give me an error saying you can't use double, but I could call it, double total or double something. I just can't use a command in place of a variable name. And then a couple suggestions that I have. I suggest a technique called Hungarian Notation. And Hungarian Notation is a technique It's not a programming skill. What it does is it says that you start your variable name off with typically three characters, three letters to describe what that variable name is. Okay, we'll talk about that in just a second here. But let's give some examples of some variable names, and then we'll get into the Hungarian notation. So again, you want to choose a name that's descriptive. Notice that this example I have on the screen, subtotal or last name, that's using what we call camel case. Camel case says that you can't put spaces in, but what you can do is you plug the words together and you capitalize the first letter of the word. So sub, capital S, total, capital T, or last name, capital L, capital N. This is a technique, it's not required. And notice in the bottom example, instead of camel case plugging them together, I could use an underscore. And the underscore will make it look a little bit more readable as well. My rules in this class are I don't care what technique you pick up as long as you pick one technique up and you stay consistent with it. You don't want to mix and match different styles, you want to stick with one style. So, what is Hungarian notation? Well, Hungarian notation says that every variable that you name, you come up with a variable name and then you put a prefix in front of it that describes what that variable is or what it's holding. So I don't have to go back out and look at a variable and try to figure out, is it an integer or is it double? I know if I put an int in the beginning of the variable name, it's an integer. Or I know that if I put in dbl in front of a variable name, it's going to be a type double. Now, that's nice when you look at your code. It's not a requirement. I don't require it in my classes. But I'm going to tell you that you'll see a lot of quality programmers are going to stick with this kind of technique, whether you're a Microsoft developer or you're not a Microsoft developer. And you're going to have some that choose to do it differently. Another technique that I've seen is where, like, let's take this example right here where it says Boolean member, BLN, which is Boolean, and that would be this guy up here on the top. They would call it member and type out the entire data type at the end. Member Boolean, or day of week byte, or income single, or maybe income double. Again, that's not wrong. There's no problem with doing that because it does the same thing Hungarian notation does. But one of the things that you're going to find an advantage of using it my way is that when you start typing out a variable name, we've got this IntelliSense in Visual Studio, and as soon as I type out a B, I'm going to get every variable or object that starts with a B. And as soon as I do a BL, fill an L in, it's going to give me everything that starts with a BL. So if I type in, for example, DBL, right here for double, I'm going to get a list of all the double variables that I can choose from. And that's a nice feature when we're dealing with Hungarian notation. So let's get back and talk about declaring variables. I showed it to you in the beginning. Now we're going to go back and revisit it. We're going to do it on our own. So right here, I'm declaring a variable called double income. Notice that it doesn't have a value after it. If you were programming in the C++ world, I'd have to declare this as double space double income equals 0. And the reason is that some languages manage memory for you and some languages manage partially the memory for you. And in the world of C#, when you declare a variable and it goes out and grabs that memory location, if you don't tell it what its starting value is, it's going to set it automatically to 0. So this definition you see on the screen here, the line underneath this, it would see double income as having a value 0 because it was never declared. Whereas in the C++ world, when it goes out and grabs a memory location, you have to prime it. You have to tell it what that initial value is. And part of that reason is when it goes out and says, this is the area that I'm going to use for memory, it knows that that memory is not used, but it doesn't know that it wasn't used in the past. So you might throw that variable out there, and underneath it, when you grab that memory location, it may have 32 in there. And all of a sudden now your value is 32 and you never assigned it. So you have to do double income equals 0 to wipe out whatever might be in the C# world. But the in the C++ world, in the C# world, they're automatically set at 0. Okay, so let's take a look at this in action. Now what I've got here, folks, is I'm starting up a new demonstration here. Okay, now when you've been watching the videos on the Channel 9 videos or the LearnVisualStudio.net with Bob Tabor, he's showing you how to write applications that are at the console app. That means he wants to write a program where all you focus on is the programming constraint that he's talking about. So it's very important to watch those videos. Most of my videos I'm going to show you, I'm going to relate them back to object-oriented programming. So I'm going to do them with a Windows form application to show you that we can do it both ways. Okay, so right now I'm starting up Visual Studio. I've got C# chosen, I've got Windows chosen, and I want to do a Windows Forms application. And it's by default it's going to store it at this location, which is in My Documents. We talked about that in the very first introduction of Visual Studio that I did on week 1. Now I'm going to change my location on here. I'm going to move it around a little bit here. And let's see what I've got. I'm going to put it right here in this 146 folder. So I'm going to select the 146 folder on my drive C, and I'm going to give this a name, variable demo. So we're just going to focus on variables right now. Notice that the name of the solution is the same name as the project. I'm going to go ahead and click OK, and it's going to build that entire project for me with a blank form at the top. It's going to take just a moment. So it's building all that initial components, and our job is to add the objects, but it's going to give us one initial object, and that's going to be the form, because you can't write a Windows form application without having a form, no different than you can't go out there and paint a painting unless you have some surface to paint on. So you're going to have a canvas or a paper or something. So they initially give us this very first object here, this Windows form object. And what I want to do now, just for now, is I'm not going to be fancy. I'm just going to do a right click and I'm going to view my code. Okay. Now, in a Windows form application, what they're doing is they're going to separate the code out. I want to just show you something briefly. There is complicated code from dragging and dropping. So if I drop a button right here, okay, that code is being written in a different location. So I'm over here looking at the form. This is what I'm at right now. Notice it says Form 1. If I look at Form 1 over here, Form 1 has a Form1.cs, C#, and then a Form1 Designer.C#. In the early days of writing programs, when you did your dragging and dropping, Microsoft maintained one file. So as you drag and drop, it would put all that complicated code into the file that you were looking at. And unfortunately, students would go back in there, or developers, and they'd tweak a little bit of that developed code, and they'd screw everything up. So what Microsoft did is they decided, for safety's sake, and also to reduce the number of phone calls into their help desk, let's separate that data out. Normally, in the object-oriented programming world, all your code is in one location. But what Microsoft has chosen to do is they've chosen to separate out the code that we write, which is this code right here, we'll talk about it, versus the code that C# or Visual Studio generates for us, which is this designer code. You don't want to mess with this designer code. Look at this. Now I'm going to open this up. This is all the code that it just built for me. There's that button that I just dropped on, and here's the form. That's everything, and this is all the drag and drop code. See, so I've only got a form and a button, a form and a button. If I came back over here and I dropped in a checkbox, okay, now let's go back to that designer code again. Now you're going to see there's my checkbox that it just threw on in here. And when I modify my properties over here, so if I take this guy and I said, okay, I want this checkbox now to have a background color of, oh my gosh, let's find something like this gradient active here. There's my background color. So it changes to gradient active. If I go to that code behind now, the stuff that I don't want, in here, you're going to find that here is where it made that code, that background color, for me in the background. I didn't have to do that. So Microsoft is separating it out. First of all, folks, that's code you don't want to be with. If you ever get into this code for right now, immediately get out of it. Just come back up here and close it out. You don't want to be in there yet. Later, I'll give you some examples of maybe why you might want to go into it. But for right now, let's just leave that alone. Okay, so let's go back in. To get to the code in here, I did a right click and I view code. It had opened up my basic code. So the program right now, folks, that I'm working on is this part right here. this is the important part. This out here is what's called the namespace. The namespace is kind of a container that holds all my classes. We'll talk about that later. But the program really that I'm working on that I want to deal with is this section right here. I'm not going to worry about this guy here. Let's come back over, and what I want to do now is I want to simulate clicking this button. So when that button is clicked, I want something to happen. Okay, so for right now, I'm not going to name anything. I'm just going to double click on that button, and when I double click on the button, it's going to open up the event handler that says when this button is clicked on, here's the code that I want to run. So I do that, and boom, it takes me there. Let me go back here. There's another way I could have done the same thing. Okay, I could have also gone back over here into my properties window, and the properties, remember, sets the properties for this entire area here. So I could have gone with the button over here selected. Okay, what I could have done is gone to my lightning bolt here, and these are properties, but the lightning bolt are my event handlers. Remember, clicking this button is an event. Rolling across my mouse is an event. The question is, do I want to do something when that happens? And if I do, I'm going to code the event handler for that. So in this particular case, I'm going to code button1.click. So what I could do, if it didn't exist, I could have just double clicked here and it would have created it for me. Now I can do the same thing. It's going to take me to the same location. So what's the better way to do it? It's up to you. Okay, you obviously have to create an event handler at some point in time. So it just so happens that when I double click on a button, it's going to open up the most common event handler it thinks the button has, which is the click event. That's this guy right here. Okay, we'll play around with this a little bit more. We're really focusing on variables. This will come to us as we go on here. So I'm going to go ahead, double click on this again, and now I'm in this chunk of code right here. Right here. I'm going to create a variable. Just want to create a very simple variable. Let's create an integer variable, and I'm going to call it int total. Okay, so I'm going to do int total here, and I'm going to hit my semicolon at the end of it and click outside of it. Now, what's happening is I've declared that variable. When I click on that button, it will declare the variable for me. It's not going to do anything else right now. The underlined green that you see here is a warning. If you highlight it, it's going to tell me that you've declared this int total variable, but you never have used it anywhere in your program. This is a really nice feature because as you change things and make your program more efficient, you may end up adding variables later or removing variables. You need to remember that if you don't need a variable any longer, you need to pull it out. And this is a great way of knowing which variables are not being used. So first of all, that's how I declare a variable. If I want to declare a double variable, I would do this. Double, and I would then use, in my technique, using Hungarian notation, I could do something like double total here. Okay? Now, C# is case sensitive, which means then that if I create another variable like this and I call mine int total, it's going to work. Because these are two separate variables right here. I have a variable with a capital I and I have a variable with a lowercase I. Now before I go on, I want to show you the value of IntelliSense. So blah, 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 I'm writing a program, and the moment I want to be able to get a list of all my integers. Let me come back here, and I'm going to change this around a little bit. Let's make this int subtotal. And I want to explain the importance of Hungarian notation. So the moment I type in int, notice what happens. Everything that I have access to that starts with int pops open. And if I do a t here, look at this. Anything that starts with int and has a t in it, you'll see here's my int total right here. And I can click on that and it will type it in for me. That's your IntelliSense. IntelliSense tells me what I have access to based on where I'm at in my program right now. And I have access to all of these different variables. So that's how I declare an initial variable. I'm just telling it, I haven't done anything else with it. I just said, I want to set aside a memory location. And before I go on, I'm going to put a stop here. Oh, it won't let me put a stop. So I'm going to put a variable down here. I'm going to say something like int subtotal is equal to, let's just put a value in here, 55. So now what's happening is I've now on int subtotal I've assigned a value. This should go away here. It shouldn't be underlined in green because it now sees I've got a value assigned to it. At some point that's going to go away. Okay. Now I'm going to put a stop right here. And that red stop says when my program runs, before it does anything, I want to stop on that line before it runs this line. This is a great feature, folks. It's called a debugger. It lets me watch my program that normally would run, in nanoseconds or really milliseconds. It lets me stop it and watch it run line by line. So what happens is when I click the button, it's going to declare this variable, it's going to declare the double variable, it's going to declare this int variable, and then immediately it's going to stop right here and let me go back in and look at something in my program. This is a really cool feature, folks, so watch this. I'm going to go ahead and start my program. It's going to compile it to an executable. At some point, it's compiling. It should happen quicker than this in most cases. Here we go. Okay, so here's my application running. So I put an event handler around this button. I said when I click this button, I want this code right here to run. Now notice that as I roll across it, I could have a rollover if I wanted to. I could have a tab. So notice here, I've clicked on that. As I tab, I can tab back and forth. So I could say, look, when I gain focus, that means when I tab to it, I want something to happen. There's a lot of different event handlers that we can choose from, and that's the beauty of object-oriented programming. That's where our creativity comes in. Okay, so now I'm going to click this button. When I click the button, this code's going to run, but it's going to stop right here. Watch this. See it? Now it's sitting there waiting for me to run it. If I want to continue running it, I can hit the continue button and it will run totally. Or if I just want it to run one line at a time, I can use this button right here to step into, or I can press the F11 key. See how that works up there? The very top. So what I want to do right now is I want to know what the value of int total is. So if I point to these guys, watch what happens. It tells me int total has a value of 0. I told you that a minute ago. Automatically, variables when they're declared have values of 0. This double has a value of 0.0 because doubles have decimal places in it. And look at this int total now. Pardon me. Int total also has a value of 0. But look, I'm assigning 55 to int total. Or excuse me, int subtotal here. I'm assigning 55 to it. Why doesn't it say 55? Because this line has not run yet. Right here. It's telling me it's waiting to run that line. So now if I hit this F11 or the step, so I'm going to step right past that line, watch what happens. Boom. I passed it. Now watch what happens when I point to int subtotal. It now has a value of 55 in it. Okay? So what we've looked at here is, without doing anything fancy, I'm going to take that stop out. What we looked at here is how to declare a variable, and so far how to assign a value to that variable. Let's create a string variable here and do the same thing. So I might do string, and by the way, whether you use a capital string or a lowercase string, they both produce the same output. Microsoft does this for legacy purposes. Okay, so most variables start with a lowercase s in here. Okay, and I want this string to be str username here. Okay, now what I'm going to do down below here is I'm going to assign a name to username. str, there's my U I hit, and there's my IntelliSense popping up. I can either hit that or I can tab through it and it will type it in for me, is equal to Tom, and close it out right here. Now I'm going to go ahead and let's put a stop right here and let's run this guy. Okay. Now none of these guys exist. These variables do not exist in memory. They only exist when you click the button. This is kind of like a little tiny program. So when I click this button here, it's going to run this tiny little program where it's going to declare the integer, it's going to declare the double, it's going to declare the subtotal, and it's going to declare the str username. It's going to assign 55 to one of the variables, and then it's going to stop here before it assigns Tom to str username. So let's watch what happens. Boom. That quickly. So now if I point to int subtotal, I better see a 55 pop up because it's already run that line, so it does have 55 in there. But if I point to the string, look what the string value is. It has a null. Now, whereas a numeric variable will automatically assign a value of 0, you get a null value, which means an unassigned value, it's never been used before, to a string off the bat. Okay, so now what I want to do is I want to step through this line right here, boom, and let's go back and point to str username. Notice it has Tom in it now, but also notice that it has quotation marks around Tom. That's telling me that it's a string, it's text information. Look, if I point to int subtotal, notice the 55 is in it, but there's no quotation marks around it. That tells me that that's the numeric 55. Check this out. Let's change this program just a little bit here. Okay, I'm going to call this one str subtotal. Okay, and in it, I'm going to put a 55 right here. And in fact, let's not do a 55. Let's put 66 right here. And I want to show you the difference now that's happening here. I fat fingered that one. Total, subtotal, str username here. Let's change that. Okay, so I've got this str username that exists down here. Okay, and I've assigned it 66. Now notice the difference between the two. This is an integer type and I'm assigning it 55. This is an str username and I'm assigning it 66, but there's a big difference. Notice the quotation marks here. Here I'm assigning the value 55 to this integer. On this guy, I'm assigning the character 6 and the character 6. If I tried to add str username with str username, I'm going to come out with 6666. It sees it as a string. It's like plugging them in together out here. And let's take a look at this and see what it looks like. Let's put a stop right there. This time let's rerun it. Click the button. Okay, now if I point to int subtotal, notice the 55 in there, right? There's a 55 there. We haven't run this one yet. It's null, so let's step into that line and let's see what the difference is. Now notice the quotation marks around the 66. That's telling me that's the string 66. It's the string 66. And oftentimes there's numbers that we're going to want to put in there. Let's check this out. Let's jump back over here and let's call this social security number. Or let's do student ID. So SID here, and we're going to do STR SID here. So I'm declaring a student ID up here, and down here I'm assigning that student ID, and let's take a look at what happens here. So let's do a my student ID 101-00-1181. Okay, so now notice it let me do that. If I check this out, if I forgot to put the apostrophes or the quotation marks in here, I'm going to get an error. It's going to say, whoa, 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 whoa. This is a number. You're trying to assign a number, 101 minus 0 minus 1181, into a string, and you can't do that. This cup is different than this cup. This cup says, I expect a string, yet I'm plugging the wrong information in. Okay, so I have to put quotation marks around it to make that work, and I'll never need to do math on it. Notice the quotation marks here. Now let's come back up here, because I do have an integer. What's going to happen if I did this right here to this integer? Control V, without apostrophes. Well, basically, folks, what this is going to work, but it's going to give me a formula. Check this out. Let's put a stop right here and let's run it. Okay, click the button. Boom, it runs this. So now, look what happens when I point to int subtotal. It says it's a minus 1080. Well, how the heck did it come up with that? Because it took the number 101, it subtracted 0 from it, and then it subtracted 1181. This, by the way, would be an example of a formula that we would put in. So it shows you how there's a big difference, and you can't do it the same way. You would never want to store something like this to an integer, because this is non-numeric, a student ID. It's non-numeric. So let's continue on with the slides and come back. We'll visit this again in a second. So exposing objects a little bit, I just want to talk a little bit about objects and go back and show you what we can do. I can store a value in a property of an object. So here I've got a text box here, and notice I'm using Hungarian notation here as well. TXTs for text boxes, LBL for labels, so I try to be consistent across the board. But I've got one called textAge.text, and that's going to always be of type string. Now notice it's an age and I expect it to be a number. But in objects like this, I can only store string information, which is going to cause us a problem. Well, not a problem, but we're gonna have to address that down the road. Now notice I have another one down here called textAge.enabled. That's a type Boolean. Either that text box is usable, it's enabled, or it's not enabled. So that's going to be either set to true or false. And then I got another one down here called textAge.size.height, and I've got a dot width as well, and that's type integer. That lets me set how wide I want that text box to be. Now normally if I drag that text box on a form and I drag it out manually like this, let's go back to my form here. So if I drag a text box onto the form, where's my text box? There it is, here. Okay, I can programmatically control how big that text box is simply by grabbing it and just resizing it here. Okay, I can do that. In fact, I can even go a step further. There's a property on here called multi-line. Now notice I'm in the event handlers over here, folks. I'm not looking at where I want to be. I want to see properties, and I'm in event handlers, so I need to click over here on properties. And if I look, there's a thing called multi-line in here, and notice it's a Boolean setting. It's set to false. If I change that to true, watch what happens. It now lets me take that text box and make it much bigger. Something like that. But anything that's in that text box will be of type string, period. Okay, so let's jump back over here, and we saw an enable. Let's look at the height example over here. So if I look at size in here, there is the height. So right now it's 148 and 71. The width is 148. Keep an eye on that right there and watch when I change the width of this and let up on it. It's 148. Now I let up on it. It made it 189 over here. Or if I wanted to manually change it myself, I could say, you know what? I want to make this back to 140 again. And as soon as I click out of it, it made it back to 140. So an example of sizing that object just a little bit. But notice that I can store values inside those text boxes. So when I come back over here, let me put a stop. Let's go back into my program here, and I'm going to put a stop right there. Okay. Now, what I want to know is I want to know what the value of that text box is. I'm going to show you a new cool feature, and let me take this line out here. I don't want that line in there right now. So we're going to leave that stop in there right now. Okay. Excuse me. We'll leave that stop in here, and I'm going to run this. Boom. And now, when I run this guy, the first thing that I'm going to do is I'm going to put my name up here, Tom. Now, the moment that I click out of it, Tom is stored inside of that text box, but that text box is a massive, massive object. If I need the text box, then great, store Tom in it and retrieve Tom out of it. That's a great thing. But if I don't need the text box, I certainly don't want to just store Tom in here just to store it. It's got to have a purpose here. Now watch this. I'm going to click on this button. Now the challenge is I don't have that text box displayed up here anywhere. But if I view, and I just happen to have it open here, this watch window, check this out. If I go back over and I come down here and I view and I pick out all other windows, inside here there's going to be a watch window. Or what I could do is I can highlight something like this, do a right click on it and say add to watch right here. And what it will do is it's going to move that strid down here, and rather than me have to point to it and have it tell me there's a null, it means that it's going to tell me as I run what that value of strid is here. Now right now it's a null, but if I step one line into it, notice it changed it immediately to the new value. But what else I can do is I can come back in here, and I've got this object over here right now that's called, I believe it's called textbox1. I haven't given it an official name yet. So check this out. If I come over here to text box, there's my text box 1 right there. This is not the same. This text box above it is different. We'll talk about that. But the name of the object is text box 1. If I'm not sure where that came from, then I can come back over here, grab the text box, and I'm running the program to stop it here. With the text box selected, I can go to the name property and it tells me it's text box 1, or with it selected, I can look up here and it's going to tell me the name of the object. So if the checkbox is checkbox 1, the button is button 1, and if I threw another button on the form here, it would become button 2. And the default caption on these buttons, by the way, is the name of it. We'll talk about that in just a second. That's not the focus yet of this. Okay, but let's go back into the code. So now what I can do, let's rerun it again and get back to that, my code. Now what I can do is I can come down to my watch window, and there's IntelliSense here. I can type in text, or excuse me, txt, and anything that starts with txts or has txt in it's going to pop up. There's my text box 1. Now I can do .text here. And the moment I do that and click outside of it, it's going to tell me what is currently in that text box. And currently in that text box is nothing because I didn't type anything into it. So let me go ahead and continue running it. There's that text box. Let's type Tom in. And again, notice that I can be changing this around while I'm running the program. I'm going to click the button again. It stops back there again, and now notice what's in text box 1. It's Tom. Now, again, it's not stored in text box. Text box is the object. If I asked it what's in text box here, check this out. I can double click here and back up. It's going to change things around. It's going to say, whoa, whoa, wait a minute. Text box is an object now. You're not asking me for a property. This is kind of cool, but a little bit more complicated. If I open this up, it's going to tell me all the properties in text box, and look right here is text, and there's Tom in there. So I can ask for a specific property. For example, if I want to know, is that text box enabled? Okay. What I could do is I can come back over to my watch window. Let's close this out, and I can do this. I can say dot, oops. Let's go back to my text box 1. Dot en, and there's enabled property. Click it, and I see, yeah, that text box is enabled right now at the point of where this program is right here. It is enabled. Okay, so it gives you a little bit of background on that aspect of variables. Let's jump back to the lecture here. So again, the idea is I can store information into these areas, but if I just want to store information, these are overkill. But it works. You saw that work. And a text box is an object, and it's made up of properties, and it's made up of methods. And we have a text, these are just examples. I've got a text property we just looked at. There's another one, there's a method called lost focus. So at this point now, just to give you an example of how the event handlers work, maybe when I leave this text box, I want something to happen. Okay? What does that mean? That means that maybe when I hit the tab key, I've left it now. I've now come down to button. When I leave that, I want something to happen. Okay, so what I do is I'd highlight that text box. I come over here to my event handlers, and I'm going to look for a leave event in here. And there's a whole bunch of event handlers, folks. In fact, I could click inside of this and use a click event, just like I can on a button. Not one I would use commonly, but I could. And when I gain focus, when I enter that text box for the very first time, I might want to have something happen. Okay? Or when I leave that text box right here, I want something to happen. So I could either type in the name in that I want and go ahead and hit enter, and I don't want that to be the name, or I just click here and it opens up the event handler, and it's telling me now this is a leave event handler for text box 1. Okay? What do I want to have happen? For now, maybe what I want to do is let's change the text on this button right here. Okay? Because remember, I can impact everything in my program. So what I want to do now is when I leave that text box, I want to change that button's name on there from button 1 to maybe the word clicked. Okay? So let's see how that's done. So if I go back to my code, I've already created that event handler. There it is. Right? And the name of that button is button 1. I need to know the name of it. Okay? So let's go back to the code. So the moment I leave that text box, I want, and I'm typing out button 1 dot, and the text that appears on this button is going to be, we're on event handler, let's go back to text. The text that appears on it is button 1. Okay? I could put hello on it, and that's the text on it, is hello. Okay? I'll leave that there for now. So now, I'm going to go back to my code, but notice what it was. It was the text property. When 99 times out of 100, folks, if I'm dealing with text on a button, a label, in a text box, I'm talking about the text property. That's probably going to be one of the most used properties in an object to use is the text, because that's what's going to give us back the information maybe that the user typed in. So, okay, so when I leave that text box, what I want is I want button1.text to be equal to clicked. Okay. So I've got two different event handlers in here. I'm handling the event for leaving the text box, and I'm handling the event for clicking the button. I'm not handling the event, though, for rolling over that text box. I'm not handling that event. I could do that if I wanted to, but again, as a programmer. But let's just take a look and see what this is going to do. I'm going to take this stop out right here. Okay, and let's rerun it. So I could type anything in here I want, but the moment I hit my tab key or click outside of that text box, and by the way, the term that I use here is this text box right now has focus. Focus means that's the current selected object within my form. I have focus. Now when I click when I click this button or hit the tab, I'm losing focus. Now watch what happens. I'm going to tab out of it and watch the label here. Boom. Clicked. Right there. And I could watch it happen too. Watch this. I'll put a stop right here. Okay, let's rerun it. Okay, I don't have to type anything in. I just have to leave that text box. So I hit the tab key, and it stops me there. And if I say, what's on this button right now, it's going to say, well, it says hello. It hasn't run this line yet. But now if I step past it, boom, and I go back and ask it, now it says clicked. But I need to continue the program running for it to show it to me on the screen. So I'm going to continue it running, and there's my clicked right there. So talking a little bit about objects, a little bit out of the focus or out of the scope of variables, but it's important right now for us to understand because I need to be able to show this to you before I can give demonstrations. So we take a look at a lost focus or a leave event. We have a text property. Okay. Now, one of the things I want to talk about real briefly, and we're going to spend enormous amount of time on this in our next course, in the CIS 256 course, and that is the concept of public and private. Okay, if I come back over here, everything that happens in this program right now is happening privately, which means that when I run this program right here, I cannot have an outside program running that looks and manipulates this guy at all. Why? Because everything internal is private. That's called encapsulation, folks. That means we're making sure that the only thing people need to get to on the outside is the stuff that I make available in my program, but they don't need to read it from the outside. Later, we're going to have a form that might open up on the outside that may need to read this information. If that's the case, I'll need to change that information to say, yep, you can read this piece of information outside of this form. For me to do that, I change it to public. But you'll notice right here that right now, everything, right now, see how it says private here? This means that technically if I run this program, if this was public, I could actually write a program that would click this button outside of this form. But right now, by making it private, that means that the only way I can click this button is physically clicking it, just like that. It's the only way I can do that. So that's the concept. I could make this public here. Don't want to do that. But now, technically, if I was outside the program, I could actually run this method and change that to clicked. There certainly will be a time later we want to do that, but not necessarily right now. It's just important to understand that code here, what this public and private means. I'm going to turn this back to private again. So later in class, in writing programs in classes, I'm not talking about, when I refer to classes, I'm not talking about a course. I'm talking about everything that we deal with here. Let's go back, is a class. Notice that here it says it's a partial class. So this is all a class. Everything that we do, folks, in object-oriented programming, somehow, whether it's Ruby, whether it's Java, whether it's C++, C#, we're always going to be working with classes. We should recognize that from that Geek Speak document that I had you read before. When we run this program, when we run it, this class becomes an object. So right now, technically, this is still all a class, even though we talk about instantiation as moving it from here over here, it becomes an object. That's maybe okay, but really technically they don't become objects until boom, right now. Now it's an object. Here, this is a class, this is an object right here. So I guess the point being about this public and private that I really want to relate is when you write a program, there's certain things that you're going to want the people that use your program to be able to see, and there's certain things that you want the user not to see. So when I come back to this text box right here, for example, everything that the developer of this text box wanted me to see, they made public. And everything that you see here in that text box's design was made public originally. So the ability to turn background color on, to turn it off, the ability to go back in and put a border around it, the ability to go back in and make it multi-line like you see here, those were all designed within, when that text box was designed, they were designed as a public feature. But when I run this object right here, there's a lot of things that this text box can do that I can't get to, but I shouldn't have to get to them. For example, it knows to type information in, or I know that when I highlight it and I hit to delete, it deletes it out, right? I know that I can grab text from a different source, copy it, come back over here and paste that in. And how does it know how to do that? They don't show me that, folks. When they designed this text box, they said, there's things I want you to see and there's things I don't want you to see. Okay, there's things that work behind the scenes that make that text box work that I don't want you to fiddle with, but there's things that you need to have access to make that text box usable to you. You need to pull information out, you need to copy it in. Backspace, you don't think much of it, but there's a lot of code involved in that backspace that you're looking at me do right there. Where was that written? That was all written privately. So an example of that, let me get back to my PowerPoint slide here, might be a zip feature. I can write into my program a zip feature, which means then that I can, in my program, I can write it so it grabs a bunch of data, it zips it and writes a zip file for me. So publicly, they give me the access to pass a file to that zip and tell it what my output file is going to be. But nowhere in that zip routine are they going to show me how it does all the magic and compresses everything down, because I don't need to see that. And that's going to be important for you as a developer, because that allows you to hide all your intellectual information. For example, in a media player, okay, if I want to drop a media player onto my form, I don't know how it converts those bits into video or into audio. All I know that it does it and that I can make it work with my application, and that's the cool thing about object-oriented programming today. So we understand that basic concept of public and private. We're going to spend an enormous amount of time on that in 256. But we're going to also talk a little bit about scope of a variable too. But before I go on, let's talk a little bit more about some shortcuts in dealing with variables. This slide here shows me how I can declare a variable. So up to this point in declaring variables, I've used this top method. I declare the variable as a data type, and then down below it I might say int hours equals 30. When I declare this initially, it sets it at a value of 0. But there is a shortcut, because this comes from the C++ world. Remember, I told you in C++ when you declare a variable, you have to immediately give it a value. I can take advantage of that in C#. So this next line down here declares a variable called, it's a single precision variable, which means it's going to have decimal places in it. It's going to be called single tax rate, but I'm going to give it an initial value on the same line I'm declaring it of 0.082. Okay. This next line down here says I can declare multiple variables on the same line by separating them with a comma. So in this case, I'm declaring an integer int day of the week, and I'm setting it initially to 5. I'm declaring an int month day, and I'm setting it to 3, all on that same line. Now I could declare the two variables without the equal, so I could have said int weekday, comma, int month day, and both those variables would have been created with a 0 value initially. But in this case, I'm declaring the variable and I'm assigning the value at the same exact time. Just a shortcut. A Boolean variable is no different. This variable right here, when I declare it, it will default to false automatically the moment you declare a variable. I have to physically set it to true if I want it to have an initial startup value of true. So I'd say Boolean, BLN, member equals, and actually the word true without apostrophes around it would set it to true. You can also use numbers if you want, but normally we're going to use true or we're going to use false. So there's some shortcuts in declaring variables. So let's go back and talk a couple of more rules about variables. All variables in the C# world have to be declared before they're used. You can't just arbitrarily go out there and say total equals 55 without declaring total. You have to declare it. There are some languages that will let you get away with that. But what they do is they use the shotgun approach. They'll use what's called a variant data type. And a variant data type says that whatever value you put in this variable, it's going to automatically take on that data type. So if I say subtotal equals 55, subtotal automatically becomes an integer. The problem with it is that because it's a type variant, it's going to take up 16 bytes of information. It's not very efficient from that standpoint. Okay. So some data types must be properly cast when converting from one type to another to avoid loss of data. That's going to be one of the focuses that we work on within this module, is how do we convert from one data type to the other. Some languages like Basic Language or Visual Basic didn't care. I could move 12.0 into an integer and it would just drop the 0.0 and make it 12. But what we're going to find out is Java, C++, and C# all require us to treat apples to apples or oranges to oranges, which means that if I'm going to move an integer into a double, I have to convert that integer into a double first, or I should convert that integer into a double. Or if I'm moving a double into an integer, I have to. And we're going to talk about casting here shortly. Let's talk a little bit about how we assign values to a variable. This is more formula based, or how do we put formulas in. So for those people that took algebra, piece of cake. But I do want to point one thing out before I go on, and that is the differences between what we're going to do here, which is called computer math, versus what we do in algebra. Computer math and algebra look a lot alike, but there's a big difference. Algebra returns to you what is referred to as an equation. And the equation says in algebra what's on the left side of the equal sign has to be equal to what's on the right side of the equal sign, and your mathematical responsibility is to make those equal. Okay? That does not work in computer math. So for those of you that are not real big lovers of dealing with algebra, we're going to simplify it a little bit. In the computer math, what we do is the formula will always be on the right-hand side of the equal sign. It will always solve the right-hand side first, and it's always going to plug the value into a single entity on the left-hand side. So in this case, we're taking 22 divided by 7 times double radius squared. So this is really pi times the radius squared is what it's doing. And whatever the radius is, it's going to move that into an integer over here. So in this case, I can only have on the left-hand side of the equal sign a single entity. It could be an integer variable like it is here, or it could be something like I'm putting it directly into a text box. If that's the case, it would be textbox.text equals. But it's always going to be a single entity on the left-hand side. Okay. Another thing to point out too, and let me see if I can real quickly here. Let me jump over and open up my notepad here. So in algebra, you might have something that looks like this. Let me format this here just a little bit. Okay, give it a little bit bigger font. So in algebra, you might have something like x equals 5. Very common. All that's saying is move 5 in, and every time you see an x, you're going to be seeing a 5 instead. But look at this. If you try to do this in algebra, you're going to get in deep trouble. X equals x plus 1. Okay? That in algebra is impossible. You can never have a number equal to itself plus 1. I mean, if x was 6, that's like saying 6 is equal to 6 plus 1, or 6 is equal to 7. It's impossible. It's impossible. If you try to do that in any algebra class, you're going to fail. But in computer math, that works great, because remember, it always solves the right side first. So let's assume that we have this line up here, like that, in the program. Okay. What would happen is it never sees that to begin with. It's always going to look at this first, and it's going to say, well, what currently is x? X is 5. 5 plus 1 is 6. Now, x is now equal to 6. So it just reassigns x. This is a great command. This is what's called an increment command. I'm incrementing x by 1 each time, but that will never work in algebra. So let's close this out. Let me get back to my PowerPoint slides here. This is a little bit longer lecture than we would normally look at. Let me open those up. And let's get back to this slide just one more time and look it over. So here I've got a formula and I'm going into an integer. Here I'm doing concatenation. I'm plugging in the first name, a space, and the last name, and I'm moving it into a variable called str full name. So if the first name was Fred and the last name was Flintstone, I would have Fred with a space after it, Flintstone, in str name. So remember, it solves the right side first and plugs it into this variable. And again, I'm assuming that str full name was previously declared as a string. Notice down here, I'm putting a literal in str first name, and this is obviously should be str full name. Fred Flintstone is going in. I'm not mixing it with anything else. I'm just plugging a literal in directly. And down here, let's not worry about some of the commands in here, but all I'm taking is I'm taking the information in 2 different text boxes. Okay, I'm adding them together and dividing them by 2, and I'm going to call that the average. So it's going to do all the math on the right side first. When it's done with that math and it has a single answer, it's going to plug it over here in int average. Let's talk real briefly about date-time variables. So I told you that there was a date-time data type out there that we could use when we declare a date. And you'll see an example here on the slide where right here I declared a variable called today of date time. If I was using my naming convention, I probably would have called it DTM today for a date time today. Okay. But as soon as I do that, date time opens up the door to a lot of cool stuff. What I can do in here is I can add days, hours, milliseconds, minutes. I can all kinds of cool things that I can do with that date time variable. I can take one date and subtract another date from it and find out how many minutes or seconds or hours or days there were between that, which is extremely powerful for me. But I have to declare that as a date time variable for these guys to work. We'll talk a lot more about date time as time goes on, but it's a very valuable feature. Here's some examples of the converting a date time to a string. Now, if I want to put date time back into a text box or into a label, remember date times are of date time and a label is of type label. That means that I have to cast, and we're going to talk about casting here. But what if I take a date time and I pass, if I use a method that follows it. So I need to back up a little bit here. Folks, objects and sometimes variables have they have built-in properties, but they also have event handlers that we can code, but they have methods as well that we can use. So remember, if you go back to that geek speak, we have properties and methods. Methods, there's different types of methods. We have an event handler, which is a method that we tie to some activity that happens on the program. But we also have methods that we can create our own, which we'll do in the 256 class later, or we have methods that Microsoft has provided to us. And these are some methods that are pre-existing methods that we can use that allow us to format dates and times. So if I have a date and time filled in, okay, I can come back and say whatever that date and time is, I want it to be formatted to a long date string. No matter what that date is, it's going to put out the day of the week, the month, the day, and the year. If I do a too long time string, it's going to print the time out in this format right here. If all I want is a standard short date string, then I could use it and print it out like this, or I can have a simple time string print out. And we're going to play around with that a little bit more as time goes on as well. So use closely with the datetime variable. The datetime object is an object that we can do some cool stuff with. We can ask it, is this a leap year? We can ask it the number of days in the month, but we can also use a parse, and we're going to talk about parse here shortly. Parse lets me convert a date into a string. Because remember, I told you apples have to be converted to apples. So if I've got a date and it's a date time, and I want to put that date time, let's just come back over here and take a look at that here. Let's say that I want to put, when I click this button, I want to put the short version of today's date in that text box right here. Okay, so I'm going to show you I'm going to show you one way to do that right now. So when I click this button here, I want to put today's date here. Okay, so when I come over here, I click that button. Let's take all this out here. I don't want to do that right now. What I want to do is I'm going to create a date time variable. Okay, so I got date time here. That's a variable, and I'm going to call mine today. Okay. Now I can leave it alone like that, and it's going to leave the date pretty much null. No date in it at all. But what I want to do is I want to start an initial date. And there's this object that floats around. This date time object not only is a date time property, but it has some cool stuff in it. Watch this. I can do date time dot, and there's one in here. There's two that are very similar. There's one called now, and there's another one called today. They both basically bring up the same thing. It's today's date. And notice over here that it's not telling me that it's a method, so I think I just type it in just like this, hit a semicolon at the end. And now when I click the button, it's going to put today's date in this variable. Let's test it out and see what happens. Okay, let's run it. Click the button. Okay, so right now if I look at today, it's going to show me today because it's showing a default date. It has not been declared yet. It's kind of strange that it does that. Now, if I look at today, though, over here, it's got today's date on it and the time that I'm doing this lecture, January 18th of 2017. Okay, I want to move that into today's variable. Okay, let's just step through that. And if I point to today now, it's got today's date on it. But look at that format that's there. All I really want is this format to show up in that text box. So what I'm going to do now is, let's stop this program. I'm going to hit the stop button up here, stop it. Is I'm going to go back to that text box 1 that we've got here, dot text, and I want to make that, text, and I want to make that equal to today. Okay. Now when I do that, I'm going to get an error, and it's going to say, I'm sorry, you can't do this because today is of date time, and I cannot go from a date time into a string. That's a string. But what I can do at the end of this, because it is a date time, is I can hit a period, and it opens the doors up to a lot of cool stuff. I could take today and add hours to today and move it into that text box. I can add seconds and move in that text box, whatever. Okay. Or there is a toString method, and I've got all these methods here, so I could say, let's go to a long date string. Let's do a long date string here. Okay. Now notice at the end of this example, it's got closed parentheses here. That's telling me that it's a method. So remember from geek speak, methods always have to end in these parents. So I'm telling it now that when I click this button, create a variable called today, and then move today in a long date string method into that text box. I'm going to take the stop out and just make it happen. Watch this. Boom. So I get Wednesday, January 18th, 2017 to print out, even though they didn't put that in there in the same format. Let's change this format around. Let's try to a short date string. In fact, let's try dot to short date string. Okay, close it out. Semicolon at the end of the line. And let's rerun this. So I go ahead and click hello, and now I get the short date string printed out. So in order for me, and we're going to talk about this in a minute, to allow today to go into this text box, because that's of type string, I had to cast this or convert today into a string, and that's what this statement right here did. Not only did it convert it to a string, but it also let me format it too. Okay, I could put it in raw if I wanted to. Raw is simply a dot to string. And I've got that here. Just a raw data. Let's take a look and see what that's going to do. And that may be just all I want. There's my raw. That's the basic format that the date comes in. That might be perfect for me. But I may not want the time to show up. That's where short date string comes back. Okay. So let's talk a little bit about a scope of a variable. A variable has a life to it, and it depends on where you declare a variable, where that variable life is. And why do they have a life to a variable? Well, let's go back and take a look at this code that I just put in here. Okay, right here I declared this variable right at this point. Okay, when I declared the variable, it is of type today, and I just needed to move today into this text box, and I didn't need today any longer. So the scope of the variable basically says is I only really need this variable for a short time, because every time I click this button, it's going to recreate the variable, and whatever the date and time is, it's going to plug it into that text box. I can prove that. Okay, I do a hello, and every time I click it, it's going to plug it in. I don't have milliseconds showing up, or you would see a difference up here, but as the time changes, it would continuously change that. So we say then the scope of this variable is only needed within this button one click event. I don't need this variable anyplace else because I'm using it right here. So there's no reason to declare it at we call class level. I can actually take this variable right here and move where I'm declaring it and keep it alive the entire program. Watch this. If I take this variable right here, and I've declared it right at this point, but if I declare it at the very top of my program right here, okay, now I take this line out right here. Boom. Take that out. It's still going to work just fine. And what's going to happen is when I run this, you'll see no difference. Still going to put the date and time in. But now the difference is that date and time is going to stay alive the entire time my program is running. And I really don't need that. I only really need it right here in this point. Grab the date, plug it into the text box. But right now, it's going to be alive everywhere at any point in time. If I wanted to on this button, check this out. I could put today on this button. Today dot, oops, let's try that, toString. Now it's not going to all fit on that button, but I could do that because it's alive everywhere. Check it out. It still worked, right? It's alive in that button directly. But the challenge is I don't need it. Now, if this was the case and I wanted it to happen, sure, I would have to have it declared where it is because I need to get to it down here. But if all I need it right here, let's move it, let's get rid of this. And let's replace this right here. And now watch what happens. Oops. Now let's watch what happens. This works fine, but now I get an error down here saying, wait a minute, there's no such variable as today. Why? Because today was only alive within the block it was created. Let's talk about this a little bit. Okay, so we have three different types of scope. We have what's called a method scope. We have a form scope, which is also called a class scope. And then we have what's called a block level scope. And basically what it says, I go back to my program here, wherever a variable is declared, it only stays alive between the brackets on which it's declared. Which means that that variable is only alive here. It doesn't exist down here. But let me go back to the way we had it before. I'm going to Control Z here. Okay, so here we had it before. Now notice here's where the variable is declared. That means that it stays, there's the top bracket, it's going to stay alive throughout all of these brackets right here. So any place in my program, I can get to that variable. Now you might be inclined again to say, why not declare all your variables at the top? And you can get away with that sometimes. The challenge is it's going to waste a lot of memory that I don't need to waste. I don't need that variable when it's declared is going to stay alive here. I'm going to use it here. And the moment it sees that bracket, it's actually going to wipe that out of memory entirely. That's why I was getting that error down below here, is that it already wiped it out of memory. So let me give you more examples of scope. Let's put this into perspective. And let's talk about American laws. If a law is passed inside the United States, if the federal government passes a law, we would say then that that law has a scope or a jurisdiction, if you will, on the entire country, which includes all states and all territories and all property flying the American flag, which would be embassies and that such. So it's bound, it's universal. It takes the scope of everybody. So if a law is passed in Washington, D.C., a federal law, Washington State's still bound by that federal law. Okay? And no state or local law can supersede that law, technically. Now, let's go a step further. What if a law is passed in the state of Washington? Well, if a law is passed within the state of Washington, we would say then that that law has a scope of only in the state of Washington. Any place in the state of Washington, any county, any city in the state of Washington would have to abide by that law. Okay? But the moment that I step out of the state of Washington into Idaho, that law doesn't exist anymore. Idaho does not have any responsibility to Washington state laws. So we would say then that the scope of a Washington law is only within the state of Washington. So if the law is created within the state, it only has a scope within that state. And we can go a step further. I could go in and say, okay, let's take Spokane County, Washington. If a law is passed in Spokane County, it only has an impact in Spokane County. If you step foot out of Spokane County, Ponderay or Stevens County or King County, they don't care what the law is in Spokane County. It doesn't have, there's no jurisdiction there. It doesn't have a scope outside of that. Very common. This is how variables work. So if a variable is created in a particular routine, it only has a scope in that routine. It ceases to exist. So if I'm standing in Washington, okay, and let's just take the marijuana laws, because that's the big hoopla now. If I step foot in Idaho, those marijuana laws don't exist. It's illegal in Idaho. But stepping back into Washington, as long as I'm within those borders of Washington, those laws take effect. So again, how does it correlate? It correlates based on an example I gave you just a minute ago. This example I have on the screen is a class level variable. Notice that here's my definition of the class here on the top, and generally class level variables are going to be, they don't have to be, but they're going to be declared at the top, right after your class statement here. Okay, you're going to declare your variable. When I do that, that means the entire class, that variable, this error message variable, is going to be alive. Okay, so again, just like where a law that's passed impacts the scope of that law, basically where it is assigned, the variable is impacted based on where that variable is assigned. And the easiest way to remember this, folks, is look at the brackets preceding and following it. Those brackets are what decides the variable ceases to exist. Okay, so going back to my example here, if I declare this as a class level variable, that means the entire time this program is running, this is the entire program, that class level variable will be alive. But if I declare that class level variable between these brackets, it's only going to be alive in these brackets. The moment that it hits that bracket, that variable is going to be wiped out of memory if it was declared here. So again, I showed you an example of a class level variable a minute ago. We have a method level or a local variable right here, message. So that message variable will be usable in this code, but the moment that that bracket hits, when it's done running this method here, or this event handler, that variable message will cease to exist. If I ask it in any place else in the program what the value of message is, it's not going to see anything. It's going to say that variable doesn't exist. So a method variable is one created or dimensioned within the event handler, the method, or a procedure. And those are three different names, geeky names for the same basic thing. A variable of a method scope ceases to exist when that closing bracket is encountered. Okay. A method scope variable is not accessible outside of that method. Whereas a class scope is that variable that we assign at the top. And it's going to be accessible throughout that entire program. Every place within that program, we're going to have access to that class level variable, as long as it's within that same form. Later, we're going to talk about how to have multiple forms. We're going to have a little issue there, because if I've got 3 forms, that means that a variable created in one form by default is not accessible naturally in another form. That's where we're going to go back and start playing with that public and private later, folks, but let's not worry about that right now. So block scope is different. Now, we haven't really looked at block scope because we really haven't got into looking at blocks yet, but I'll briefly give you an example of a block here and how it works, but it has the same rules, the brackets. So a block scope would be an example of an if-then-else statement, which we're going to cover in a couple of weeks. So this is a submit button, and we'll talk about, this is casting here. We're going to play with casting in a little while. But what this says is if double sales, whatever the person's sales are greater than $20,000, then we're going to run this chunk of code right here. But only if this is true, if this produces a true, do we run this. Now notice, inside here, I'm declaring a variable. And by the way, this variable right here is alive from here to here, which means I can get to double sales inside these brackets here. But also, notice down here that double bonus was created. Double bonus was only needed for a brief moment. Double bonus was needed to take your sales, figure out what 5% of your sales are, figure out your bonus, and put it back on the screen. That's it. I don't need it any longer, so when it was declared within this block, it ceased to exist here. Next time I click the button, though, it's going to go through the same process. It's going to act like it's always been there, but it's only going to be recreated every time this button submit right here is clicked. Okay? So let's jump over and take a look at an example here.